Hello everyone, good morning. I welcome you all once again to the mathematics class. Now in the last class we stopped on solving more questions on the application of the Pascal Triangle. So we want to solve a few more questions today, and after that I want to introduce the concept of identity. So from which we can now begin the journey to solving the Olympiad mathematics questions. So the last question which I have under the application of the Pascal triangle is the one we have above. So the question is x over 2 plus 2 over x raised to power 3. So we know since the given expression has the power of 3, so the very first responsibility is to ensure we determine what line of that Pascal chart or Pascal triangle chart is going to be of interest to what we want to do. So we can realize that. So if we compute that chart, so it's going to be the level where we have 1, 3, 3, 1. So since I know that is what will serve as the coefficient of my expression, so this thing will be applied. And for the sake of students, since you are learning this thing, majority of you are learning it for the first time, I would prefer you construct that Pascal triangle chart so as to be able to obtain what we have here. But as for my own case, I will quickly apply the one which, since I know it already, I will apply it. So let's jump straight into what we have to do. So we say this is equal to, and remember the principle by which this thing works. The principle is we are going to begin with this first term here by raising it to the power of 3, while the second term I have here with the power of what? With no power or with the power of 0, and I will continue like that until this one contains no power again, and this one has the power of what? Power of 3. So after doing that, then I will begin simplifying so as to what? Arrive at the final result or answer to what I have here. All right, so if I'm to do that, x over 2 squared can be rewritten as x over 2 rather will be what? X over 2 raised to power 3. And we know in order to combine this one, it has to be by multiplication. So multiply by the second term of the second aspect of the expression I have within this bracket is 2 over x. That will be multiplied by 2 over x, everything raised to power 0. So let me introduce a square bracket here. So square bracket will be here. I can now move over to the next one. So in that, either increasing and decreasing order. So to combine in the next one, it has to be by addition. So, and that's going to be, so the power here will drop by 1. So from 2, it changes to x over 2 raised to power 2. While this one, we have its power increased. So that would be multiplied by 2 over x raised to power what? 1. Then I can close everything here. I can now as well say that plus. So I would love to continue that one from this. Okay, let me continue here. And the last one will what? Be here. Now, again, in order to continue with this expansion, means that what? The power of the first term here will also drop by 1 again. So that now becomes x over 2 raised to power 1. Then the power for this one will also increase by 1. So that would be 2 over x now raised to power 2. Now, the expansion continues since I've not gotten to the target or to the goal of what we are doing. And the target is we are going to stop, the expansion will stop when we get to a point where this first term contains power of 0, right? So, and that is what we are to do now. So that will now be x over 2 raised to power 0 now, combined with or multiplied by 2 over x now raised to power 3. Just like you know that this expansion will continue until the first term contains power of 0 and the second term or the last term contains the maximum power of what? Of the given expansion. So since we have to expand it to the third terms, so once the second term contains the power of 3, that is where the expansion we're going to what? Going to stop. So from here. So we can see this expansion is not yet complete. It's not complete in the sense that I'm here to do what? To supply all of this my expansion with the value which I obtained from my Pascal triangle. So the first term of the expansion goes with this one, while this 3 here will be fixed in the second expansion. Third expansion will be allocated this 3, while the last expansion we have this 1. So after this, so then the rest is we simplify so as to obtain the final result. So let me move back a little bit because of the spacing. So here I have 1 into, now x over 2 raised to power 3. You know what that means is x times x over 2 times 2 times 2. And that gives what? X raised to power 3 over 8. So here I have x raised to power 3 over 8 multiplied by, we can see what I have here is raised to power 0. And anything raised to power 0 gives what? 1. Followed by plus 3 into, so here I have x over 2 squared. That means x over 2 multiplied by x over 2. So if that multiplication is done, we are going to get x squared over 4 multiplied by, this raised to power 1 means it should be written once. So written it once means I will write 2 over x plus 3 into, so in this case as well, x over 2 raised to power 1 means x over 2 should be written just one time. So that would be x over 2 multiplied by this one now, 2 over x squared. So we know that means 2 over x multiplied by 2 over x. 2 times 2, 4, x times x squared. So that will be 4. Everything over x squared. Then plus the last one here. So that is 1 into, right? So here I have x over 2 raised to power 0. So which leaves the value of what? 1 multiplied by, here I have 2 raised to power 3. 2 over x raised to power 3, meaning that 2 over x should be repeated 3 times over x rather. So 2 times 2 times 2 here gives 8. X times x here gives x cubed. So that is going to be 8 everything over what? Over x cubed. So in order to continue with the simplification, so I have to what? Let me simplify further in short. So to simplify further here, I have 1 into, no, x cubed. So I can as well say this is over 1. So anywhere where I have it as a whole number, I can as well express or rewrite it as what? A fractional form or a rational number by saying it is over 1. Now, so multiply numerator goes with the numerator, while the denominator goes with the denominator. X raised to power 3 times 1 here gives x raised to power 3. 8 times 1 here is 8. Plus 3 into x raised to power 2 times 2. That gives 2x squared. Now 4 times x. Or let me cut where possible before I begin carrying out the multiplication. Alright, let me say 2 in 2 here 1, 2 in 4 here gives 2. Now here, 2 in 2 here is 1, 2 in 4 here is 2. Now when this one is cut, this one will cancel and this one remains 1x. So nothing will cancel here. So we can continue. Here I still have my x cubed over 8 plus this one is 3 into, we have left here x squared times 1. That will be x squared over, right. I also forgot to cancel my x here. You know, x here 1, x in x squared, that is x. So x times 1 here gives x. 2, no, this is now 1. 2 times 1 here gives 2. Plus 3 into, here I'm left with 2 in the numerator and x in the denominator. Then plus, so we don't have anything common here. So this one will be 1 into 8 over x raised to the power of what? Of 3. So we can, here we can see 3 is common to this place as well as this place. So I can write this thing as 1 multiplied by this is x cubed over 8 plus, so we can see 3 is common to this term and this one. So I can say this one is 3 into x over 2 plus 2 over x, then plus 1 multiplied by 8 over x cubed. So that one is 8 over x cubed. And we can conclude this is what? This is the solution to this expansion of x over 2 plus 2 over x raised to the power of 3. So that is how far we can go about the Pascal triangle or the application of the Pascal triangle. So in a few minutes time now, so we'll be moving to the identities, which plays a very key role in solving questions. Now, before going to the identities, before I have to write all the given identity, let me quickly talk a little bit about this identity. Identity simply means system of solving equation or system of dealing with expression, whereby an expression that simplification that's supposed to take a very longer step can be reduced to a very short form. So that's one of the benefits of this identity. So once we know those basic identity, application of it to some given expression or some given equation makes solving such equation very easy. The other advantage this identity has is that it relieves us of stress of learning some topics. For instance, something that has to do with simultaneous equation. Once I can, there is a way I can apply the identity in such a way that student may not need to use the simultaneous equation in dealing with the question. In a nutshell, the essence of applying or using this identity is that it makes the solution to any question it present the solution to any question in a simplified manner. So that's the reason why this identity has to be learned, so that once we see any traces of those identity, so that is what we are simply going to apply in what? In dealing with the question. It makes the solution to be very fast. So that is its essence in short. Now, this is everything um, about the identity. So each of these identities is to be remembered, and they will be applied in solving questions. So one of those things we are going to come across in the exam question is will involve the application of identities. So question in identity come directly as identities. In this situation, identity will be applied. So that is one of the benefit of this identity. The other one is this identity too. It is important we know them. So when we know it, when we go to some higher topics like the AMGM inequality. So most of the concept of these identities will also be used in solving the question. In number theory as well, it also called for the application of identity and some higher factorization concepts. Then also in combinatorics as well, this concept of identities is also going to be useful there. So I will urge every one of the viewers to ensure we have the full grasp of what of this identity. How does this identity operate? Because under this identity alone, we have about 10 questions or more than that we are going to address. So, which I believe that by the time we are done with those ones, we should be comfortable in applying these identities in what? In dealing with what? In dealing with the question, and that can make the Olympia journey an easy ride. So I'm going to begin from the first one on the list here. So we can see the first one here talks about a plus b raised to power 2. So this one has value of a squared plus 2ab plus b squared. So this one is very easy to verify. So in order to verify this one, we are just going to simply apply what? Our Pascal triangle system of expansion. So when we apply that system into this thing, it's usually going to give us this result. So we are going to be using this thing every time. So how we are going to apply them, I'm pending that one till the next class, but the essence of this class is only to get us familiarized to those useful identities. So when we know those identities, how they appear, then in the next video or in the next class, I will talk more or elaborately about how do we actually apply all these identities in what? In dealing or into solving some questions. All right, so in order to get this thing, right, so there are some mathematicians who has believed that everything we have here should be memorized. And some said that when we keep solving questions and we keep applying these identities here, naturally it will become part of our system. So whereby we don't actually need to cram or to memorize, because that one may a kind of what create some fear in the student. So in that situation, so few ones that require solution. So I will quickly show to us how we can arrive at them. So for instance, a plus b raised to power 2 here, we know it looks similar to something which we have done under the application of our Pascal triangle, and that was one of the reasons why we spent so much time dealing with questions on the Pascal triangle. So if we apply this concept of Pascal triangle, it will at the end of the day produce this value of a squared plus 2ab plus b squared. So anything that involves brackets and square like this, or bracket and having power outside, we can achieve any of those values that is given to us here by applying what Pascal means, Pascal triangle ways of what of expansion. I'm going to do only the first one. For this one, this one, this one, this one, this one. Now all of these ones that I underlined here, so we can get the result which we have here by means of what? Of Pascal triangle. I'm only going to show the first one, then I will leave the rest, because when we apply our Pascal triangle too, right, it will enable us to get this desired result which we have there. So let's quickly do the first one. You know I have the power of 2, so it means I'm going to the third line of that Pascal triangle chart that contains 1, 2, 1. So that is what I will use to expand this thing. So and that becomes, suppose if we want to show the workings, so I want to expand a plus b raised to power 2, right? So remember what we said then. We'll begin with the first one by squaring it, and second one will not have any power at all. So the first one will be a raised to power 2 multiplied by b raised to power 0. Then plus the second one will be a raised to power 1 multiplied by b raised to power 1. I hope you remember why it's like this. Remember, this one will drop, one of the power here will drop, and why this one will gain such a drop. And finally, we're going to have this one contains no power again, while this one contains the full power of what? Of 2. That is, the one here will also increase by 1. And remember, this expansion is not complete until we've supplied it with the value we obtain, or we are going to obtain from our Pascal triangle chart. So remember, when we are dealing with raised to power 2, we go to the third line of the chart, which contains 1, 2, and 1. So it means I will attach coefficient of 1 to this, coefficient of 2 will be attached to this, and 1 will as well be attached to the last one. So we say that a plus b squared. So we're now going to simplify. So I have 1 into a raised to power 2 times 1, since anything raised to power 0 gives 1, plus 2 into a raised to power 1 here is a, because it's more or less the same thing as writing a once. And b raised to power 1 as well becomes b, since it also means we should write b once. And I can now say plus 1 into a raised to power 0 here is 1 multiplied by b squared. So we can say that a plus b squared is 1 into a squared times 1, that is a squared, plus 2 into a times b, that is ab, plus 1 into 1 times b squared. We can say that gives what? B squared. So we can say that a plus b squared is equal to 1 times a squared here is a squared, plus 2 times ab here gives 2ab, and 1 times b cubed here gives b cubed. So we can say this is the first identity we have on the list. So the derivation of any identity involving brackets, right? Bracket that has some power outside. So Pascal triangle system of expansion is what we are going to apply in order to determine or to get such an identity. So when we have question that has to do with this, so it means a plus b squared is equivalent to a squared plus 2ab plus b raised to power 3. Regarding its application, so I'm going to keep mute or silent about that now, but only to just tell us the whole stuff which we have on the board above. So you can now see the power of Pascal triangle we did the other time. So it is important we understand it thoroughly. So once we understand it very well, most of these identities, in case you even forget them in the exam, we easily can apply it within few seconds to remember what exactly the identity is. So what I applied in dealing with this number 1 will also be applied in dealing with the second one, in dealing with this thing, that is anything that contains brackets with the power outside. So we can use Pascal triangle to derive those results. So that is one there. Right. Now, the next one I will move to now are those that do not involve bracket at all. That is situation whereby I have each of those variable having square or having cube. Right. Now, unlike this case now, this case here, this case here, this case, as well as the last case which I have there. Though these last two cases, they are commonly referred to as special identity, and we are going to treat them specially. So all those ones that do not involve brackets, how do we arrive at them? I'm going to talk about them shortly now. So I will give little time for us to quickly copy this thing, and remember that to getting anyone involving brackets like this, apply what you learned under your Pascal triangle, you will also get the same values. And once we continue on applying it in dealing with questions, by the time we've gotten to section whereby we are going to solve questions, so naturally when we see a plus b squared, so now we will just be able to say that a plus b squared is equal to a squared plus 2ab plus b squared. So kindly quickly copy what's on the board. So I will come over to rub it shortly. All right, so remember when we have a plus b raised to power 2, so I just said it, Pascal triangle will be used in carrying out this expansion. Now, what if I am posed with this case, a squared minus b squared? So I believe this one is not new to us. So this is not the first time of seeing this thing. So the one I'm referring to now is the case whereby bracket is not involved. That is, it is not everything we combined and square. So we squared each number individually. Now from basic GSS3 work, so we have come across this one several times. So in order to deal with this one, so it has a name. So this one is called the difference of two squares. So that same difference of two squares is the identity for this one. So to state the identity for this one, we simply say a minus b against what? Against a plus b. So this is the identity for this. So this one does not require any form of thinking, right? Now the next one we want to talk about is a squared plus b squared when it appears like this. How do we arrive at this form of identity? Right. In order to obtain the identity for this thing, so one should think, from which identity can I obtain a squared plus b squared? Right? So this a squared plus b squared, right, is happens to be a member of a plus b raised to power 2. So to getting this thing, we are going to do what? To find the expansion of a plus b squared. That is, we are going to consider a situation whereby this a plus b is in brackets, having square outside, right? So doing this one now, we are going to expand this thing. I know by our Pascal triangle, expansion of this thing gives a squared, because I just did it, plus 2ab plus b squared. So we know that one very well. But what we are actually trying to find is a squared plus b squared, so which is present here, right? So in order to get a squared plus b squared, what it means is I will remove this midterm, and that shows a squared and b squared, which I have here, has been gotten, right? So in order to isolate a squared and b squared, since that is what I'm looking for, so what it simply means is I'm going to exclude this plus 2ab. So since this thing involves equation or identity symbol, so I will simply move this into the other side of the identity or the other side of the equation. So that is, I can say that a plus b raised to power 2 minus 2ab is equal to a squared plus b squared. A squared plus b squared. So this is what we are looking for. Therefore, identity for a squared plus b squared is a plus b squared minus 2ab. That is what we mean by this identity. Identity can also be taken to mean formula. Because in this aspect of what we are doing, so we are not going to be given direct formula. So we will be given something which we are looking for, and our job is to think from where can we obtain that thing which we are looking for. So, and since we know what I'm given contains two terms, so it means this thing can be located from what? From expansion of two terms with the power of 2. That was the reason for saying that this thing will be a subset of a plus b raised to power 2. And what is a plus b raised to power 2? We can expand it using our Pascal triangle or normal opening of brackets. When we double this thing, that one can as well be used. It will give this result. And remember, what we actually want to isolate, what we are looking for is a squared and b squared. So we can see a squared is here, b squared is here. So to get a plus b squared means I will have to excuse this middle term. So once I excuse it, I've already obtained what? My a squared plus b squared. So which shows at the end of the day that a squared plus b squared will be a plus b squared in bracket squared minus 2ab. So this is how this identity is gotten. Because I don't want to create a situation whereby we just write the identity and tell the student that we just memorize it and that is all. No, it do happen at times in the exam hall that something which we memorize, something which we cram will not be there. We will not be able to find it. But we also know a means by which it can be derived. So if at all we cannot quickly restate it the way it is from the identity chart, then we should be able to do what? Quickly derive it so that it can be useful in what? In dealing with the question which we want to what? Want to solve. So this is how this one is going to be dealt with. So this is everything that has to do with identity involving square, right? So that's that. So remember, this one is the usual one which we know. So we have a square that has difference in between them. So this one involves the difference of two square. It's not different from what we have learned in from our basic algebra class. While this one, the identity will follow the procedure I explained in order to determine such what an identity. Or if we easily can memorize it, there's no problem. So there will be no point in what? Going through this stress. So the most important thing is we just need to know that a square plus b square is equal to this. This is the identity for this. That is, the equivalence of this thing is a plus b squared minus 2ab. But the derivation of a squared plus b squared that was given in the identity charts I wrote the other time is this. So I will rub this now and move over to the next one. Now, the next on the list, we have a squared, a cube rather, a cube plus b cube, right? So what is the identity for a cube plus b cube? So once what we have is beyond 2 power, so what we usually do is separation technique is what we do. What we mean by separation technique is I'm going to separate this thing into two parts, right? Now, when we look at this thing, so one we should question is that we should be able to apply Pascal triangle. So Pascal triangle is not used in this situation. Pascal triangle is specifically used in situation whereby the two given expressions are in brackets, and that bracket contains some powers. So this one, so we are just going to expand this one. So it has some element of Pascal triangle, but it does not make use of what? It does not make use of those coefficients. That is, those values we are always going to check from a Pascal triangle will not be useful in deriving the identity for this. But every other thing we do under Pascal triangle will be useful. All right, so under that expansion of Pascal triangle will be used. So what we are going to do initially is I'm going to separate this thing into two parts. One part will contain a plus b, right? So the expansion of this is a plus b. So I want to separate it, then the rest will be something that has the square, right? So a plus b that has no power will be written first, then followed by a squared, right? So we are not just writing a square. So if we want to show what happened fully, so I can show it here. So just like what the expansion we did in the previous classes, so what we're actually going to do is out of these three terms, one are here. So it means we have two more terms. So in order to represent those two terms, we are going to apply that increasing and decreasing order of expansion. But we will not introduce Pascal coefficients. So that's just the difference between this one and the one of Pascal triangle. So now we are left with a squared and b squared. So how do we now expand this a squared plus b squared? So the idea is the first one will take the whole squared, while the second one will what? We have low power. Then minus is the rule. So if what we are combining has plus between them, right, we'll be alternating the sign, right? In the second bracket, we'll be alternating it, starting from minus, right? Now, the next one is now going to be a raised to power 1. You know, in this case, this b will gain value, abi. We say b raised to power 1, then plus. So we'll be alternating the sign if what we are looking for is what? Addition of cube or addition of n powers. So plus, now this one will drop 1 again. So it will become a raised to power 0, b raised to power 2. So once we get to this stage, this is where we are going to stop. But the only difference between this and the expansion we did the other time was that we will not introduce all those Pascal coefficients. So Pascal coefficient will be useful when what we are dealing with here they are inside bracket and it contains just one power, not a case whereby we distribute the power to them individually. So to wrap up with this, we simply say this is what? A plus B into, remember this means A squared times 1 minus AB plus 1 times B squared, which is the same thing as A plus B into A squared times 1 A squared minus AB plus 1 times B squared B squared. So the identity, so if we relate it to the table I gave the other time, we are going to see that the expansion of A cube plus B cube, right, the identity for it is this, or the way to expand this thing. So when we are solving questions to the stage whereby we come across A cube plus B cube, so what will normally happen is we will replace this value with the value of A plus B against A squared minus AB plus B squared. But pending that time, let's just try and understand how these identities work, so that when we'll get to an aspect where we'll be solving questions, we will know how these identities are applied. Now, it's also possible for the case of A raised to power 3 minus B raised to power 3. It's more or less the same thing we are going to do. So the identity in this case is going to be, remember, when it contains power above 2, that is from 3 upward. So that is when we use what I call the separation technique. We usually separate it into, this thing I have here will now be separated into 2 brackets. So the first bracket will be a case of A, just A and B, containing no power, and with the presence of sign we have here. So that's going to be A minus B. So the second bracket is exactly the way we carried out the expansion when we did that one of Pascal triangle, but we not involve the Pascal coefficient. But it is the same reasoning, same mode of expansion, only with the exception of what? That Pascal coefficient. So remember, out of the 3 powers, we've removed 1, so it means we have 2 left. So it means, so the first one here, we are having square now. So it is square we want to occupy this entire bracket now. So therefore, what we have left is A squared minus B squared. Now, how do we now expand this A squared minus B squared? So remember, firstly we are going to say A squared multiplied by second term here, right, will be B raised to power what? All right, let's say this thing means A plus minus B squared, if we can recall. All right, so let me say A multiplied by, what I have here is minus B raised to power 0, minus B raised to power 0 plus, remember, we begin dropping the power now. So the power for this one will drop by 1. We say A raised to power 1, right? Then multiply by, so what I have there now, minus B raised to power 1, right? Minus B raised to power 1, then plus, this one will drop power once again, A raised to power 0 multiplied by minus B raised to power 2. Minus B raised to power 2. So we simplify to get the final result. So which becomes A minus B into, this is A squared multiplied by anything raised to power 0 here is 1. Now, here I can still say plus A raised to power 1 is A, minus B raised to power 1 is minus B, then plus A raised to power 0 here is 1, minus B raised to power 2, that gives B squared, which becomes what? A minus B against what? A squared minus AB plus B squared. So which is the identity for A raised to power 3 minus B raised to power 3. So I will rub the board shortly. All right, so let me quickly rub this now. Now, the next case is this. Now, what I would not love to go here yet. When we have done some aspect of factorization, because there are some students that are yet to hear about factorization here. So I will leave this one now. So let me move to the last one here. So when we have learned that concept of factorization, because this one, if we want to derive what we have here, it involves some aspect of factorization, which I will leave for now. So let's move to the last one. There we have a raised to power 3 plus b raised to power 3 plus c raised to power 3 minus 3ab is equal to a plus b plus c into a squared plus b squared plus c squared minus ab minus bc minus ca. All right. So this is when we have an identity that look like this, or we have an expression that looks like this, right? So it will be equivalent to this. That is, in the process of solving my question, so dealing with equation, so if at the end of the day it lead into something similar to this, something that has this pattern, right? So it means its value will be equivalent to this. So the position of this thing now, I will replace everything I have here with what I have here now. But it's subject to one condition. So when we have this type of standard, it is important we first of all check the A plus B plus C, because this one is referred to as a special case because it has two patterns. So one of the pattern is, this is one of its pattern. It can look like this, right? And the other way around, this same thing I have here, a cube plus b cube plus c cube here, can also be written as 3abc. 3abc can also be written as 3abc. On one condition, does this thing changes to 3abc. So what I'm saying in essence is, when we have this thing in the question which we are solving, by the time we solve to the level whereby we have this, we automatically change this to this, right? And at times, we will not change it to this, we'll just change it to 3abc. So on what condition do we change it to this? And on what condition do we change it to this? So it will be left in this form if addition of A, B, and C is not equal to 0. Once combining A to B to C by addition is not equal to 0, therefore, this identity I have here will be equivalent to this. So in that situation, what I have here will replace this thing in any question that I'm solving. So it may look somehow now. By the time we begin applying it to solving question, we will understand it better. So the other case is, so that is why it is important when we have this case. So it is called the special case. It is termed or referred to as a special case. So once it's a special case, it is a must to check for sum of A, B, and C, because it has two forms. So it's a chameleon something. So it can appear like this, and at times it can appear like this. That is, this whole thing can be written as this, and this whole thing can be written as just 3ABC. So the condition for having it as 3ABC is if addition of A, B, and C is 0. So because if addition of this, and this is 0, this 0 will affect this and render the whole of this thing to becoming 0. Meaning that we are now going to say this minus this is equal to 0. Or let me write it this way. Since when whereby we check this thing and this gives 0, right? Because if this is 0, it will be 0 multiplied by everything I have here, a squared plus b squared plus c squared minus ab minus bc minus ca. So, you know, the result of multiplying the whole thing here by 0 changes everything to 0. meaning a squared plus b cubed plus c cubed minus 3abc will be equal to 0. So which is the same thing as saying that what? A cubed plus b cubed plus c cubed is equal to 3abc. So we need to exercise a lot of care when dealing with this special case. Remember I told you two cases are referred to as special case. So this is one, this is two. But because we've not discussed factorization at all, so I will leave this one for now. So possibly before I begin solving question in the next class, I will quickly talk about factorization. So when we are done with the factorization, now we now make mention of this. How is this one used to derive this? Right? So we talked about how this one is used to derive this. So pending that time, so let's say every other thing we have done together with this is those basic identities. So, and I will love it that we should all go and walk over it. We should relate with it many times as possible, because the result of this thing we are going to see in the next class how these identities are used in dealing with question. So remember, I will say it once again, we are still laying the foundation to dealing or tackling the Olympiad standard questions, or let me say the Olympiad styled questions, and everything has to start from the foundation. It will be important we understand this foundation very well. So once this foundation is very clear to us, I promise you that solving those Olympiad style questions will look somehow very easy to us. So we won't have any challenge in dealing with these questions. So let's try and grab this thing as we are doing it. You can see we are not rushing. We are trying to do it little by little and step by step. So hope to meet you in the next class. Thanks for watching.